Atari and sort of my quest to build a custom Bluetooth controller for one. So you're going to learn about both of those things today. And my name is Cory Faris. So we're going to talk a little bit about retro gaming. We're going to talk about some retro game consoles that I assembled and put together, and then a few fun projects that I had for customizing and making something that I think is pretty unique. So just from a show of hands maybe, how many of you have dabbled in retro gaming, emulation, anything like that? All right, so some familiar faces with it. When it comes to retro gaming on a Raspberry Pi, which is what I was doing about 6 years ago when this happened, there's two main flavors of operating systems. So there's Recalbox and there's RetroPie. RetroPie is probably more popular than Recalbox, but when I was experimenting with this, what I found was that Recalbox felt more polished. RetroPie feels a little bit more customizable. In my use case, I was giving these as gifts to family members. I didn't want them to see terminals and other non-smoothed user interface experiences like that, so I went with Recalbox, and it worked out pretty well. If you're doing this for yourself, by all means use RetroPie if you'd like to have a bit more customization. So the first case I bought to stick a Raspberry Pi in to try to make it look a little bit nicer rather than just having a bare Raspberry Pi playing video games from, looked like an original Nintendo. And it's cool, it looks like an original Nintendo, but it was boring. My first thought was, I want a power button. I want the buttons on the front to actually do something. So if something doesn't do what you want, this is sort of my message to you today. If something doesn't do what you want, make it better. So I immediately cut that power button molded plastic out, and I stuck a momentary switch behind it, an LED, a resistor, wired it up to the GPIO pins on the Raspberry Pi, and bada bing, bada boom, I had a functioning power button with an LED indicator, so I knew when my game system was on and when it was off. I posted this on Reddit at the time, and the company that made this case actually reached out to me and said, hey, that's really cool. Are you a case modder? Like, are you a hardware modder? Do you do this for a lot? I'm like, no, I bought your case for $15 and I didn't like it, so I made it better. They're like, would you like to be part of our beta testing program and we'll send you free stuff? I'm like, yeah, send me free stuff. So they eventually sent me their Super Nintendo version about a year and a half later, which incorporated a functioning power and reset button and a few other things that I'd recommended to them. So that was a nice improvement, and I feel like I had a little bit of an impact on the world that day. But while I was waiting for them to come up with better cases, I found another company called RetroFlag. And if you were building it today, this is probably the brand of cases that I'd recommend from what I have seen recently as I put this talk together. At the time, I bought the NestPi case. Now they have the NestPi Case Plus, which solves some of the issues that I had. Because immediately when I opened it up, I thought, this is awesome. They have a power and a reset button that actually work. They have additional circuitry to make this cooler, but it was done all wrong. So the power and the reset button didn't function properly. Both of them were on the same, they were wired in series. The reset button just toggled the power and it did a hard reset. It would corrupt your SD card if you use that regularly. Not a good situation. So what I did was I also noticed that a lot of the wires in it were too small for the voltage. You'd get bad voltage readings. So I ended up cutting the tracers on the circuit board. Again, I don't have experience doing this. I just wanted to make something better. I rewired it. You can see some of the wires that I had added on that printed circuit board in order to change the circuit for the power and reset buttons so that they were independent of each other. They ran to separate GPIO pins, and I could have them communicate with the Raspberry Pi on their own. I replaced the power wires with thicker gauge wire to avoid low voltage warnings, and then I also added a Python written soft shutdown script so that when you press the power button, it doesn't just kill the power, it tells the Raspberry Pi to shut down gracefully, and then when that completes, it sends a signal to the MOSFET chip in the bottom left there that you can see. And then that will actually cut the power to the Raspberry Pi, so you no longer have voltage going to the circuit board to avoid damage. And this was a pretty big improvement, but it also was a lot more work. But I had fun doing it. My wife didn't quite understand why I was cutting apart circuit boards, but she appreciated the finished product, I guess. So then this is the script that I ended up using on that case, I believe. The power button will do a soft shutdown. The reset button won't actually kill the power. It will exit out of the emulation station and go back to the main menu, sort of how you'd expect a reset button on a video game system to work. There's newer scripts than this online that you can find on that GitHub page from RetroFlag. Some of the new ones actually save your metadata too, which is a great addition. And so Christmas comes, and I give 4 of these game systems to siblings. Not shown in this presentation, one of my siblings really loves Lego, so I just gave him a bag of Legos and said, build your own case. I did give him instructions for it, but I don't have a picture of that one. And so my dad says, oh, those are great, those are really cool. I want one too, but don't put all that effort into it. I just want something really basic. All I want to play is Atari anyway. And so I thought, okay, Dad, Atari it is. So I had a year until I figured I'd gift my dad an Atari. So how am I going to build an Atari? So that, for those of you that don't know, this is what Atari 2600 looked like. And step 1 was I went to Goodwill, and I bought 2 Atari joysticks from original Atari joysticks for $5 for the pair, I think it was. And I stared at it for a few months trying to figure out how am I going to have this work with a Raspberry Pi to play Atari games. But we'll come back to that. First, I built the Atari. The top left is a 3D model I found online designed for the Raspberry Pi 3. And I modified that in several different ways, made it look more like the original Atari with the correct proportions, and made it fit a Raspberry Pi Zero, because this is it doesn't need to have the power of a Raspberry Pi 3 if my dad only wants to play up to Atari games. Terrific. I also added some metal pegs to simulate the switches on the Atari, and there's 4 metal pegs in the base there to hold the Raspberry Pi Zero. So as you can see with the Pi Zero in there, I made it as small as possible to still fit the Zero while keeping the proportions the same. I also added a functional power switch, because that left-hand switch on the Atari was a toggle switch to turn the power on for the system. Mine doesn't toggle. It's just a momentary switch that you press, but it turns the system on and off, and it runs that same type of script to do graceful shutdowns as the Raspberry Pi 3 ones did. And there it is for scale. You can see just how small it is. I also have it sitting here, so you can see it is a tiny Atari. I don't know if I could make one smaller, at least not with a Raspberry Pi Zero. So now we come back to how to control it. I've got this joystick. It would be kind of boring to give my dad a tiny Atari to play Atari games and not give him an Atari joystick. Sure, you could use any Bluetooth gaming controller to play with these, but that's not what I wanted for my dad. So how to work the joystick? I thought, well, I could run wires from all of the contact points to the GPIO pins, but then I've got a long cord, and who knows if that's going to work. I want this to be wireless. Well, I could use RF transceivers. I don't know if that's going to work. I could use a Bluetooth transceiver. Oh, Bluetooth is sexy. Let's figure out how to make Bluetooth work. So I go online, and I figure I'm not the first person to think of this. Somebody else knows how to do this. So this was 2017, 2018. I did a Google search for how to build a custom Bluetooth controller. And all I found were forum posts of other people asking the same question. Nobody had a good answer, so I thought this is going to be harder than I thought. I happen to have a Bluetooth module in a box from like a hardware kit or something, HC05 Bluetooth module. So I'm like, all right, this needs an Arduino microcontroller and some power. and I'm going to have to program it all. And I dabbled with it for a little bit, didn't really get anywhere. So I moved on to attempt number 2. Adafruit makes something called a Bluefruit LE for Bluetooth Low Energy, and it sends a keyboard signal. It has Bluetooth, it has the Arduino capabilities. You still need to give it power, and it easily pairs with a Raspberry Pi. The problem, though, was that keyboard signal. At the time, keyboard signals weren't supported for Recalbox. I think they might have been for RetroPie at the time. I have since confirmed that it does work now. So if you were to do this yourself, I might recommend you go that route, or similar Blue HID board, which is a little bit more expensive, but that top one there sends a gamepad signal, which should work perfectly for what I was doing. But so if you want to do it yourself, figure out what your use case is and choose the hardware that's best for you. My thought was, I'm going to take a controller that already exists, because somebody already made this one really small. This is an 8-bit DOE 0. Now they have the 8-bit DOE 0 2, which is a little bit better. But this was the smallest Bluetooth controller I could find. All I had to do was take it apart, change the location of all the buttons, and make it look like a joystick. So that's what I did. I took it apart. There's what it sort of looks like on the inside. I needed to move the buttons to where I wanted them and hook it all up to the joystick. So I first figured out where all the tracers went, what buttons did what, and then unfortunately the test pads that were on the PCB did not correspond to the buttons. The test pads were for testing the circuitry independent of whether the buttons actually work. That bottom left there is pointing to small circles on the circuit board called vias. That's where the tracers are sending signal between PCB layers, so it gives a little bit more contact surface. I wasn't able to solder directly onto the pads where the buttons actually press. That material I couldn't solder to, and I couldn't scrape it to expose anything that I could solder to. So I ended up using an X-Acto knife, removing the insulation, the insulative coating above the vias on the circuit board, and soldering straight to that. And 6 years later, it still holds just fine with that magnet wire on there. I tested the controls, made sure all the soldered joints were correct and worked well, labeled the buttons, or labeled the wires, and then I shoved it inside the joystick. You can see I had to cut away part of the PCB of the original control board for the Atari. Just look at how different that circuit board is to this one. So, and then I started drilling some more holes, because this tiny controller has all the buttons for a Super Nintendo. I don't want to lose functionality if I've got it. So let's add some more buttons, and then my dad can play up to Super Nintendo if he wanted. So drilled some holes, added some tactile switches, did some really poor soldering, but it was early in my soldering career. Hot glued it all in, added some more hot glue for some strain relief on the wires. Made sure to line up the holes for the start and select button, because I ended up not wiring separate buttons for that. I figured I'll just stick it on the side of the joystick case, and then it'll all work. And the original PCB, it functioned, but it didn't give very good haptic feedback. It felt really just sort of stiff. It doesn't move much. It doesn't have a satisfying click. So I decided to 3D print my own and just attach some momentary switches in there, soldered them all together. You also have the action button on the top. I made a momentary switch for that as well. And then put it all together. And ultimately, this is what it looks like. It's not the most ergonomic design, but it's an Atari joystick. I mean, they weren't really going for ergonomics at the time anyway. So I feel it fits the bill. I also added a 3D printed start and select button, as well as L and R. You can tell which one is the start button because it has the star. Get it? Okay. Thought it would help me remember at least. And then the final product with the joystick and the Tiny Atari together, The Atari has a micro USB and mini HDMI that come out the back. I put all the instructions for how I did this online at the time, and then I posted that to all the forums that people were asking the same question I had. And I said, it's not necessarily the best solution, but here's a solution if you'd like to copy what I did. And then it comes down to, if I'm making a really cool system like this, you can customize the splash screen when you turn the system on. So what would you want the splash screen to look like? And what would you want it to do? And so there was a university in Norway that actually built a tiny Pac-Man board measuring less than 1 millimeter across. And I believe they did this, it's on a silicon wafer. And they then loaded it up with single-celled organisms and multicellular organisms. And they posted this video on YouTube. And they're like, hey, have some fun with this. Add your own sound if you want. And it looks really cool. I'll fast forward a little bit here. Oh, maybe not. Yeah. All right. So that's not gonna let me fast forward. But I then took that microscope video that they published online and made really cool, and then I added my own audio and made that the custom splash screen on my system then. And so I'm gonna plug into audio here. And then you can see so this is then what turns on when you turn on the system. It plays this audio 35-second video clip. So it really gets you into the mood of playing a Tiny Atari, I think. So that's the splash screen, and for technical reasons, for technical reasons, I wasn't able to show you that on the system itself because of the audio, but if this worked, maybe it worked. This should have booted up while we waited. The demo gods may not be smiling on me today. But that's why I had the video there. Are there Okay, oh, it is booting? All right, so you don't have audio on this one, but you have the video, and then I can demonstrate that the controller does, in fact, hopefully do something today. Are there any questions that anybody has?
Just a comment.
Yeah.
I think it's funny that you made this really kick-ass Pac-Man video for the system that had the worst version of Pac-Man.
I agree. I think this Pac-Man video is better than any Pac-Man game. Again, University of Norway. I can tell you exactly who it was that made it and give you the sources if you want to find the video yourself and do anything with it. But so then it boots into Emulation Station, and it should give us a menu with the games that we can choose from. And I'm just about up against time, so any other questions or comments? So then I'll just press my Start button, and maybe. No, it's doing something. I think it was left on in my bag for a while. There we go. So there's wrong Atari. Here's the, and then I'll just go into a game. But yeah, so that's the Tiny Atari and the custom Bluetooth controller. Thank you very much.